Am I here? Hello? I think I'm live. I can't see myself here. I cannot see myself up there yet. Um, but I guess we are starting. Uh, Hello. Can you guys see me? Can you say hi in the chat? Like, hey, yes. All right. Oh, hello. Oh my God. Um, Hi everyone. All right. Full disclosure, I'm kind of nervous and I'm very overwhelmed about everything that's going on. The chat, the window, all the screens that I have, all the chat going on crazy. Oh my God. So, and I'm very, very overwhelmed and thankful that I see there's almost 100 people in this thing. I did not expect such a response. Thank you very much for everyone who's here joining. I've seen, well, I mean, the chat has exploded. I'm already seeing like a lot of familiar people on the chat, people that I know in the physical world and people that I somehow know in the digital world as well. Thank you very much for joining. Oh, 105 people. Okay, you guys are making me very nervous right now. Okay. Um, well, I can't really follow up with the chat. It's kind of exploding, so I'm just going to focus on the live stream. Okay, so hi everyone, and welcome to the first edition of what I have named the Computational Design live stream. We can probably work together on finding a better name for this because it's obviously not very catchy, but I think it reflects what I want to do with this project, which is I want to start a series of live streams where I touch upon topics related to computational design, and I'll probably discuss a little bit what I think that means to me. But I'll be super happy to also hear from you guys on the chat what computational design means for you. I'm probably not going to be able to catch up on real time with what's going on the chat, but I will definitely read through it when I finish the live stream. So whatever it's there, I will definitely read it and reflect on it next week. So feel free to pour your thoughts there. Okay. Um, Let me start simple. Let me start with who I am. My name is Jose Luis, and I consider myself a computational designer. Sometimes I call myself a creative technologist, sometimes a creative coder. It depends on who I'm talking to. But in general, I'm a designer by background. I'm actually an architect by training, but my interests these days are more in the field of design, art, creative coding, a lot of computational geometry. I'm very interested in digital fabrication as well. And I'm actively doing a lot of research these days in robotics and machine learning. So I want to make this place a forum for discussing other topics and maybe sharing some of my findings with the community and to make this knowledge somehow like persistent on YouTube so that people can come and check it out at some point later. I am originally from Spain, hence the ridiculously long name that you can see right there, up there. That's my full name, and the Spanish accent, obviously. But I do live in Cambridge, Massachusetts right now, so right next door to Boston, because I currently work at the Harvard Graduate School of Design. I teach technology courses there, and for example, this semester I am teaching a course called Enactive Design, where we're exploring human-machine collaboration for creative purposes, for creative tasks. I've seen some of my students already in the chat. I see Katarina right now. Hi there. Um, and for example, last semester I taught a big lecture course on structures. I have a lot of experience in designing and calculating structures. And I taught a foundational class on Introduction to Computational Design. Actually, okay, so let me do one thing. Let me move a couple things here and there, And let me show you, I'm gonna switch to screen mode like this, exactly. So if you go to YouTube, um, and you type something like, for example, intro, computational design, Harvard, then you will probably run, yes, nice, nice, thank you, YouTube. You probably run into my all, so we made a lot of effort last semester in recording all the lectures and putting them up online for everybody to see. And actually, I have received a lot of really nice feedback and really nice words. I just received a wonderful email like 10 minutes ago from a woman from Brazil who was following the videos, and it really touched my heart. So I guess what I want to say is that there's a playlist with all the lectures that course, and I plan to keep doing this as much as I can. So if you want to get a taste of the kind of things that we will be touching upon on this live stream on this channel, feel welcome to go here. If you don't have anything to do and you don't have a social life, just go through the whole thing and you probably learn something, you know. And if you're locked in your house because all this new situation is making you, then you have some time to procrastinate, then you probably can learn something new with this. Um, um, I hear. Oh, is that Dan? Hi Dan, how you doing? This is my new live stream. Yeah, it's. I'm gonna talk about you in a second, so stay there. All right, so where was I? I have some notes about what I wanted to cover today as an introduction. Um, yeah, so which brings me back to why are we here? So, as I said, actually, I've been meaning to start this for quite a while already, because I just think it's a nice thing to do, to share knowledge, and even more now that we are in a situation where a lot of our communication is mediated by digital technologies. So I think it just made sense to make this happen right now. Honestly, I have been meaning to do this for a long time, and I'm very, very inspired by the work of Daniel Schiffman on his YouTube channel, The Coding Train. I see his in the chat right now. Let me actually pull that up as well. So I'm gonna do this, all right? And so if you here go to The Coding Train, you should definitely subscribe to this channel. Dan is amazing. He covers tons of really cool things with how to do creative coding with processing, with P5.js, with some of the tools. He has a lot of machine learning videos. Sometimes he reads random numbers. That's also a lot of fun. So you should definitely check this out. And this channel is like a huge inspiration for what I want to do. So I want to start in a very similar fashion, even though I want to take it. The topics that I will cover will be a little different, and I will probably explain that in a second what I think by that. Also, quick thing: if you want to be, whoa, there's 150 people already here. I am very overwhelmed and very thankful to all of you guys. Where was I? Yeah, so if you want to stay up to date about what I'm posting, the live streams and the videos that I will be uploading once I finish the live streams, etc., make sure you go to my channel. All right, I guess this is my channel here, and well, again, oh, I'm on live, right? I really can't click on subscribing my own channel, but so if we go back to Dan's, you can see that you can subscribe to a channel, but if you don't turn on notifications, you won't receive emails about when people go live, etc. So if you really want to stay up to date of when I'm going live, etc., just click on subscribe and click on notification as well. So where was I? Let me pull up my notes here. So I have been meaning to do this for a while, and I don't know why I was procrastinating a lot. I was kind of finding excuses. I was like, yeah, I'm doing my doctorate right now. I don't have a time for this. Oh, I have a job now, so I don't have time for this. Oh, I started teaching, but then I have to prepare my courses. I don't have time for this. Then I was very overwhelmed by dance channel, which is really well produced. So I was like, oh, I need to buy a lot of equipment. I need to get a studio, whatever. But I was talking to a really good friend of mine the other day, and he was like, Jose, I think you're just procrastinating. Just freaking do it. Just sit down and do it. And this situation is also a really good excuse to like lower the expectations on quality and that kind of stuff, and just like do it. Um, so he inspired me a lot, and then here we are today. Um, what do I plan on doing? I want to use this live stream to basically record tutorials on different topics on computational design. I think most of those tutorials are going to be very hands-on. So I'm going to be typing code on some kind of environment, or I'm going to be using like modeling tools, parametric tools to create geometry. I'm going to be covering like a lot of like practical topics, because this is a bit of what YouTube is about, I guess. Um, Regardless of whether if like here and then I may do videos that are a bit more higher level or a bit more like lecture style. But I don't have a clear idea yet. I want to run it by you a little bit, and I would love to get some of your feedback as well on the on the on the chat and on your opinion. So we can probably have like a back and forth and figure it out as we go what it makes sense to record. I will probably showcase a lot of computational techniques. I will probably sometimes showcase specific software that makes it easier to tap on those techniques. And I want to basically create a lot of tutorials that might be aggregated into full playlists. So I may want to end up doing over time like an introduction to Grasshopper, where I go from like the super basics and building up in complexity, introduction to geometry generation in Unity, and then we use Unity, which is a video game environment. But we take a look at how can that be used as a creative platform, perhaps for design or for art projects. I may sometimes do processing or P5.js tutorials, even though Dan has so much on that and is so much better than what I can do. So perhaps when I do it, I will try to do exercises or examples that tap a bit more on things that I'm interested in, like specifically computational geometry or projects that are more related to the built environment, maybe. I plan on being very inspired by the courses that I teach here at Harvard, and I would like a lot of this material to be support material for the courses that I teach, but I would not want that to be just the purpose. I would like to be the videos wonderful as standalone material that people can watch and they can learn from without having to actively participate in my physical classes here in Boston. So I, I will sometimes make some videos just because I need them for things that I want to teach in the future, but there will always be something that can be understood without being part of a larger curriculum in my class. And hopefully I plan on doing this weekly. So right now I'm recording from my apartment. But maybe when things get back a bit more to normal, maybe I can move all the set back to my office at the GSD, and then maybe I can have like a better setup, because right now I'm a little constrained. You see my hands, that's because my chroma screen here right now is super small, so I had to like so maybe I can do something better. And I also have like my laptop is like the fan is going crazy because everything is running on my laptop right now. So maybe I can get a better setup once we have free range of movement and I can get back to my office. Crazy times, crazy times. Why, if a lot of what I'm doing here will end up being standalone tutorials that will go on YouTube, why a live stream? I like, again, I like Dan's example of like using the live stream as a medium or like as a platform to like record the tutorials. So what I plan on doing is I will probably use this. Imagine this is like, it's going to be like a long 1 hour, 2 hour, who knows when, whatever time I need to complete a tutorial. And there's going to be like a lot of outtakes. Like I will, imagine like the full raw footage being the live stream, which then once done, we will chop, we will edit, and we will compose into like a shorter, more concise video that can be consumed better offline, you know? So instead of just like sitting down in my office and like recording the videos, I do kind of like the prospect of having you guys here with me, and like maybe as I'm doing things, I have questions, so I can look at the chat, and maybe people have suggestions, or maybe like I get stuck and you guys can help me, or you can give me ideas on how to continue. I don't know. I think I'm a social person, and I miss these days. I miss a lot of like the in-class teaching. So we can try this as a proxy to like teaching with an audience. And I see now that there's like 175 people. I don't know who you guys are, but I'm so thankful that you joined. I'll try to make this entertaining and and worth it. So um, so yeah. So that's why I think the live stream format makes some sense, and I like this idea. I'm also super open to suggestions. Um, I kind of have some ideas about what I want to do in the next couple weeks, etc. But I don't have like a larger plan besides what I've been sharing with you. So if you have ideas of like what would be useful for you, or what kind of tutorials you would like to hear, I'd be super happy to hear. I may not be able to cater to everyone, but I will be very happy to hear what you guys are into and what you expect from this live stream. So just feel free to like dump your thoughts on the chat. I can't catch up with that real time right now, but I'll be happy to. I'm definitely checking it out once I finish the whole thing. All right, let me breathe a little bit and drink some water. Uh, and finally, um, a lot of me, but so who are you guys? I don't know. I'm very very humbled by the response that I'm getting here, and I guess I guess I guess the audience that I think I'm trying to address with these videos are. So I guess what I'm trying to say is like I think that people who might be interested in this, you guys, are probably people who are interested in design in general and art, but are people who have like some kind of interest in technology as a way of expressing those design intents. I will be using a lot of tools and a lot of like software platforms that are very common for designers, with perhaps like a particular emphasis on people who are interested in the built environments. I'm an architect by training. The design school here at Harvard is mostly for architecture, design, sorry, architecture, urbanism, and landscape. So I will be touching upon a lot of those concepts, a lot of those topics. I will be doing a lot of computational geometry as well. So if you're a product designer, if you like making things with 3D printers, this is definitely going to be very useful for you. If you like working with robots, that will be very useful for you. And I will here and then like do some machine learning tutorials as well, because I think it has a lot of potentials these days as a collaborative um, agent in design. I'm not a computer scientist. I don't want to be a computer scientist, no matter how much computer science I may know. I'm ultimately interested in how these tools can enable us and can help us be better designers, can help us express ourselves, and can help us find a new medium with which to communicate our design intuition, right? So that's the spirit that I want to maintain for this podcast, live stream, whatever it is. And if you guys are interested in those topics, then feel free to join and feel free to check out the channel here and then for new videos coming up with this. Um, and I think that's about it for an introduction. That's a lot of people. Wow. Guatemala, Poland, Egypt, Nigeria, Singapore. Somebody is dialing in from Mars. That's kind of nice. Um, oh, I think we have Elon Musk on the show. Uh, Colombia, Zurich. Oh, Beirut. How you doing, man? Good to see you. Kathmandu, Nepal. Malaysia. Wow, this is so nice. All right. Well, maybe I can check that later on. Pakistan, Iran. That's so wonderful. It's like the UN, it's like the United Nations. Professor Sekaran, Chandra, how are you doing? Good to see you. Calgary. Oh, I was there. I was there like a month ago or 2 months ago. I don't know. Time passes so fast with this crazy situation. Anyway, let's get. Sorry, I'm getting distracted. So what are we doing today? Um, so I want to start simple because I'm kind of nervous and a little overwhelmed by everything that's going on right here. So I thought of this one session today more like a touch base and like warming up to what may be coming in the future, and also like training. I've never done this, so it's going to be bumpy. It's going to be crazy. There's going to be a lot of things not working. So bear with me with that. But I want to start simple, and I want to start by, for example, doing a simple parametric modeling exercise. And I thought that, so very typically when I start my courses, I like to I like to give my students as an exercise. I like to ask them to model a well-known building that is kind of parametric or looks like it has like fancy geometry, just to get warm up for the technologies that we will be using and the techniques. So I thought that maybe doing this here was a good idea. And I very much like, for example, I'm going to propose that we do together the Berlin Holocaust Memorial. Let me pull that up here. Where am I? I'm here. All right, so yes. So let me Google that. Yep. So this is a memorial to the genocide of the Jewish people in Germany. It's in Berlin. It's by architect Peter Eisenman, and you can see that it's like a sea of concrete blocks that all of them having like different heights, and even like a little bit of inclination to the sides. But you can see that they're laid out in a way where the surface of their boxes forms this kind of like undulating wave. I've been there a couple of times. It's a very nice, it's a very powerful building, and it has a museum underneath. So I think it's a really nice exercise to start with. So perhaps we can model that together. And I would like to do this in two parts. So I'm going to start because I also, something that I want to do in this podcast or live stream or whatever is I want to address and I want to be able to cater to all levels of expertise. So maybe you guys have never done any kind of computational design, don't know how to code, you barely know what Grasshopper is, so that's fine, and I will be doing tutorials to address people who are beginners, but I will also like to sometimes touch on more advanced topics. So with that, I would probably want to sometimes do tutorials where I assume some knowledge of the tool that we're using or the techniques, and maybe I can go faster and touch on like more specific topics that are a bit more advanced. So I would like to model this building in two parts. One is going to be like a super simple, we're just going to create like a grid of these boxes and we're going to give them the height that corresponds to the surface. So that's going to be more like the beginner side of this exercise. And the second part is going to be perhaps like more nuanced details about the particular, how this is really executed in real life. So for example, the fact that it's not a perfect grid, that it's like a parcel that has like a weird geometry, the fact that the floor is not even, but it also has an undulation, the fact that the boxes are not all perfectly parallel vertically, but they have like a little bit of like a tilt to the side, and the fact that as you get to the borders of the parcel, some of the blocks disappear. There are gaps. So if I see, so here, you can see that by the borders, there are gaps in the pattern. So maybe the second part, we can do two videos. The first part is like the basics, and the second one is more like the um, the more like the nuanced details of the project. Um, all right. Oh my God, there's 200 people here. I'm not sure if I know 200 people in the real world, but thank you guys. Thank you guys for joining. So how can we go about this? I'm going to, yeah, I'm going to use this image perhaps as a base. And as I said before, I would like to use this live stream as like recording all the raw footage of the tutorial, and then chop the tutorial into like smaller, edit it in something that is a bit more concise. So maybe I will basically start by saying hi again and like doing like I'm going to do this and so and so. I don't know. I feel very awkward talking to myself in my office here in my apartment. I don't know. I don't know. I'm a little out of my comfort zone right now. So let me take a deep breath first. Let me start opening Rhino and Grasshopper and all these things. All right. Okay. And my face is still there. Yes. And my microphone is still working. Is everything going well? I'm looking at the chat right now. Divide surface, box rectangles. Yeah, those are good components that we might use here. Hi from Panama. Hi from Boston. Lights on, Corona. Yes, I will be. Somebody's asking if I will continue doing this after the whole pandemic situation. It is my intention to do that. So I will hopefully be doing that. Yes. Perhaps better quality, perhaps in a new setup. But yeah, this is. I'm hoping to start a long-term project. Hey, Kevin, how are you doing? Good to see you here. All right. And Daniel Compel is asking, do you like Python? I guess you've seen my videos on the playlist. I do like Python. I don't have anything against Python. I think it's a wonderful programming language, very popular, and a lot of people use it. It's just I haven't used it much, and I relate better to languages that are C styled, C like C++, C Sharp, JavaScript, and even Java. I just find myself more comfortable typing them, but Python is a great programming language. I don't have anything. I just like joking about how I don't like it, but I actually kind of like it. It's if you do machine learning, it's definitely the way to go. Oh, people from Madrid. Hi, how are you doing? Uh, can you tell us what you think is the future of construction? Can I? I don't know. I don't know. What do you guys think is the future of construction? That's a very loaded. What is the present of construction? What is the past? I don't even know. There's so many shades to that, right? Okay, but should we get busy? Because otherwise it's already 30 minutes into the chat, oh, okay, I've been talking for 30 minutes already. Oh, okay. Let me, um, let me, when do I plan on doing advanced stuff? Honestly, I plan to go back and forth. I plan on sometimes if I have to do beginner introductory stuff, then I will focus on that. Sometimes I will do advanced. Maybe if I have enough time, I plan on doing this on Fridays. So maybe I can do like a morning session that is like more like a beginner topic, and then I cover an advanced topic in the afternoon. I don't know. I haven't really thought this through that much, honestly. Um, I'm a huge fan of Rhino and Grasshopper, but don't I think that these programs might become obsolete in the future? There's a chance. Everything becomes obsolete. I will become obsolete in the future. These videos will be super obsolete in very soon because technology changes so fast. But hopefully, I don't want to focus on particular software. I like using software as a medium to showcase ideas, concepts, and knowledge that is long lasting. So geometry is never going to change. It's never going to obsolete, and the basic principles are going to remain the same forever. So whether if I am using Grasshopper right now to illustrate geometric concepts, or if in the future I start using other software, or if we write the code from scratch, that will depend on the times. I just find, for example, today, April 3rd, 2020, is that today? I find that today Grasshopper is a wonderful tool. It makes programming and it makes geometry modeling very easy and very fast. And it gives you a visualization on this screen that you're seeing here right now. It gives you like a preview of geometry objects, which if you're writing in console-like environments, like if you're using Visual Studio, for example, to write C# code, it's very difficult to draw that code into a screen. You will be surprised how not straightforward that is for most programming languages. So I think, all right. So I think this environment is a really good one to start with. If I'm actually tinkering with a couple of other things these days, as soon as I feel more comfortable with those platforms, which I do think have a lot of potential, I may start like doing tutorials on them. So yeah, I'll run it by the year. Okay. 222 people. Okay. You guys are stressing me out. Okay. So, okay, let's get busy. So, yeah, so let's start. Okay. So I'm doing this because I'm gonna start like recording the virtual video for this tutorial. Okay. So I will do another introduction and explain what I'm about to do right now. All right. Dyson Lee, don't panic, Jose. Hey, Jose Sanchez. Hey, hola, ¿cómo andas? Good to see you here. How you doing, man? Congratulations for tenure. Badass. Good stuff. Okay, so let's get back to this. Let's focus. Okay, we're doing the Berlin Holocaust Memorial example, and we're starting with the first part, which is going to be basic, like the super simple. Also, I need to prepare. Oh, you guys are gonna like this. I have a sketching board, so I need to prepare that here. Okay. All right. So. Okay. Hi, and welcome to this tutorial. In this tutorial, I'm going to model with Rhino and with Grasshopper. I'm going to model Peter Eisenman's Berlin Holocaust Memorial Museum. As you can see, this is a building that is a public space. It's comprised of a grid of concrete blocks, each one of them having different heights, and all together, as a whole, they form this kind of like undulating surface on top of them. And I think this is a really nice example, like a really good introductory example to do with parametric modeling. And for this example, I'm going to be using Rhino and Grasshopper. I use this exercise a lot in my courses. So I thought that doing it here today as a tutorial would be interesting for many of you to learn something. I'm going to do this in two parts. The first part is going to be, I'm going to start with like a super basic example where I'm just going to do a basic grid. I'm going to populate that grid with boxes, and then I'm going to adjust their heights to a design surface that we're going to create on top of it. And then I will probably do a second part where I will try to replicate some of the more nuanced details of the actual example. So for example, instead of being a pure grid, I will probably adapt the grid to a parcel that is not a square. I will probably tilt the boxes because that's how they are in real world, and we will try to replicate this effect where the closer we get to the boundaries of the site, some of the blocks start disappearing, fading out. So that will be part 2 of this video. I don't know when are you watching this or how you will be watching this, but feel free, a lot of the info related to this video and the live stream that it belongs to will be on the description right here, so feel free to check it out. Okay. That would be the first introduction that will go to the video. Now I'm going to breathe a little bit and I'm going to think what I'm going to do first. I may want to draw a sketch about what I'm going to do, right? Yeah, I may want to do a sketch. Yeah, so maybe let's do that. Okay, so okay, and I need to switch to this. Okay. Before we start modeling anything, I'm going to describe with a quick sketch what I'm going to do for the first part, for the basic part. And I have this like sketching board here that took me a lot to set up, but I'm very proud of it. So what we're going to do is we're going to assume that we're going to start from a flat surface, all right, like this. And basically all the blocks that we're going to design are going to be something like this. So they're going to be displayed in an array, in a 2x2 grid, and somehow they're going to form this kind of like surface form on top of them. So in order for us to replicate this form, how do I create a new sketch? Okay, whatever. In order to create this form, what I'm going to do is, first of all, I'm going to start by creating a grid of points. Okay, this grid of points is going to serve as the base for all those blocks that I'm going to replicate. Then probably the second step that I'm going to follow is that I'm going to create some blocks on top of them. So I will be creating these blocks here, you know, and another block here, etc. I'm really bad at sketching this, right? It's very difficult to do it on a vertical screen. And then the third part that I will follow will be, once I have all the blocks, I will create, for example, I will probably create that in Rhino. I will probably create some kind of like surface on top of this, you know? And I will then take each one of those points and measure the distance to the design surface, measure that distance. And use that distance to drive the height of each one of the boxes that are going to form this monument, okay? Why am I choosing a surface as opposed to doing, for example, some kind of mathematical rule where, for example, I could use a function. I could use the sine function that you guys know does something like this. I could use a sine function. I could use a Perlin noise function to calculate the height instead of having the surface. But since it is an architectural project, it's probably my understanding that if you guys were architects and you wanted to really, really have control of the shape of this monument, you would want to have something that you can have a bit more fine, almost like touch, you know? And I think that modeling that surface on Rhino and like touching it and modifying it with control points would feel a bit closer to the real experience if you were making this model on site and you would not be thinking about mathematical functions or probably noise. You will be thinking about like, oh, I want this area a bit higher. I want this area to be a bit more depressed, right? So that tactility, I think it's nice, and we can get something close to that by modeling a surface in Rhino and then using that as the control surface that is going to drive the shape of these boxes, okay? So that's why I chose to make that. You could choose a mathematical function, that's perfectly fine. This is my choice as a designer, okay? All right, how was that for sketching? Ooh, take a break, take a break. Uh, hey, is Caleb here? Hi, Caleb. How you doing? Uh, all right. So yeah. So that would be the second chunk with the sketching that goes to when I explain this, and then so great sketch makes sense. No problem. All good. Okay. So I guess we're good to go. Hey, Diego. Diego Pinochet. How you doing? ¿Cómo andas, man? Uh, Hola, ¿cómo andas? Okay, and so the next thing that I should do is like actually model this thing, right? Let me save this before I lose. I may want to keep these sketches for some reason. May I? I don't know. Um, Maybe this can be the cover of the tutorial. This is a really bad sketch for the cover of the video, right? Anyway, um, where were we? We were about to model something here, okay? What time is it? It's 10:45. Okay, 45 minutes. Okay, so that's not bad. Okay, so let's go back to here. Okay. All right. So now we're gonna create a grid. We're going to add some sliders to control the grid parameters. We're going to create the boxes and with the height and stuff, and then we will do the surface. So we can probably do the grid now. And okay, so somebody rated, Sorab, you rated my sketch a 9.5. Well, I'll take that as a compliment, I guess. Okay. Okay. So, all right. So let's get busy. Okay. So let's start modeling this. So the first thing we're going to do is we're going to create a grid of points. In order to do that, I'm going to move this around a little bit, and I'm going to go to the vector tab. Oh, just full disclosure, guys. I'm very much an icons person. So you're gonna see that when I drop components on my screen, they look like icons instead of names. I think this is the default that you see when you install Grasshopper. I just want to say that it has been my experience that people who learn Grasshopper by looking at icons, they have a much better time remembering them because we are somehow visual. If you're using Grasshopper, it's because you have some kind of visual thinking tendencies, and recognizing images is much faster for a brain than it is to recognize text. I can tell you I've been working with a lot of machine learning lately. So am I derailing right now? I think I'm derailing a little bit, yeah. So, but maybe we can start a poll. Who is an icon user and who is a text user? You guys can, I'm an icon person. You guys can work here in the chat and say who's an icon, who's not. Maybe I can start a poll on my Instagram at some point. Are you an icons person or not? Anyway. Okay, I think I derailed a little bit, so I'm going to start over again. Okay. Okay, so let's start. The first thing I'm going to do is I'm going to create a grid of points, and for that I'm going to go to the vector tab, and I'm going to go to the grid category and use a rectangular grid of points. Just so you know, I happen to be an icons person when using Grasshopper. It's my experience as an educator that icons are much easier for beginners to remember because if you're using Grasshopper, it means that you're probably some kind of visual thinker, and remembering images is much easier than remembering text. I find that so. So I will be using Grasshopper with icons. You can change those two modes between icons and text here on draw icons. But anyway, if you sometimes get lost, I will be pointing to where these icons are on the menu. I will somehow, I don't know how yet, but I will post all these files to some kind of repository that you can download. So you will be able to see them later on. Okay. Okay, so we can create a grid of points, and then what you can see here is that this component takes a plane, which right now by default is the XY plane, and it takes the sizes of the cell and how many elements in each direction, X and Y direction, we want to have. And the result is the outlines of the cell, so the rectangles, and the planes. So, sorry, the points, which is what I want here. So I'm going to hide this component, and I'm going to connect here a points parameter box so that I can just clearly see the points here. And now I'm going to connect some some sliders here to this component so that we can control the size of the grid. Okay. So for example, the spacing between points in the X direction, I'm going to say that's going to be a slider with decimal precision 10, and now the size in Y is going to be another slider, and then how many elements, and you see that I used decimal values here. That's because we may want to have like really fine control between them. But for example, when it's about the number of elements on the grid in each direction, we may want that to be an integer with no decimal part, just because we don't want to have like 95.7 elements, right? So for that, I'm going to use a slider with an integer value here. And now I have a grid of 100 by 100 points, which are separated by 10 by 10. Okay? That's a lot of elements. I'm going to crank this down a little bit because it's going to get really busy very soon. Okay, and I'm taking a pause here right now. All right. What is next? We're going to do, next thing we're going to do is we're going to place the boxes on top of these points, but for that we're going to use planes before. And I do have an agenda of why I want to use planes. I will explain that later in the tutorial, okay? All right, let's go for this. So now that we have a grid of points, we can. I'm going to crank this down. This is very, very busy. We can probably like crank it up later on. So now that we have a grid of points, I want to create boxes on top of these points. Before I do that, let me create those boxes. I'm going to go to surfaces and I'm going to go to primitives, and here I see that I have 5 options for boxes. Okay, I will want to use, for example, I could use a lot of different things, but I think I want to use create box center on a plane, just because this can work out of the box if I plug in points, right? Nevertheless, something that I would like to do is I would like to notice that this component is asking me for planes, and planes are a much more interesting structure than points, because points only define location in space, whereas planes define location and orientation. All right, which is a much nicer structure to work with. So because it contains more information. So I would like to not let Grasshopper decide for me how these points are turned into planes. I would like to be the one who decides which planes are those that are here. And right now it may not seem very important because we're going to do, all those planes are going to be parallel to the XY, but you will see on the second part of this video, as soon as we start tilting these boxes, having those planes will be of extremely important because we will be tilting those points, those planes to create those tilt boxes, okay? So I'm just going to, here, I'm going to go to vectors and I'm going to planes and I'm going to create an XY plane based on those points, and that's what I'm going to use to feed to the boxes. I think my planes are really large on my screen size, so I'm going to go here to the options, preview plane size, and lower that down to 0.5, for example. Maybe that's a little, nah, that's fine. That's kind of good. All right. Now, the other thing that I would like to do is I would like to control the size of these boxes. For that, I can plug in values here into X, Y, and Z. So let me pause for a second. Somebody's asking if I use rectangular grid instead of square. Yes, I use rectangular because if I use square, then you can't, because the boxes are very long in one direction. It may not look nice if the grid is perfectly square. So that's why I chose rectangular square grid. I have a problem with this component, the box component. I don't think it will let me control. Oh, I think I want to use this one instead, because I don't want the planes to start to be centered on the box. I want to be able to control that the plane is the base and that they grow from the base up. Because otherwise, if they have the same direction in the same value in both directions, then basically the boxes will be mirrored on the XY plane, and I don't want that. So I'm going to redo that. I'm going to change that box. Okay. Okay. So let me state that problem in the video. So now that we have boxes that are centered on these planes, now I would want to control the size of these boxes, right? For now, we're just going to control, well, we're going to add values. For example, here, we're going to add values of 0.00 for the X value and 5 for the Y value. And we may want to control these guys something like this, all right? And you can see that this controls the dimensions of these boxes. And if we combine that with this, then we start getting an array of boxes that is a bit closer to the monument. Now, I'm also temporarily, I'm going to plug in another number for the Z height, even though we want the Z height to be controlled parametrically and to be different for each one of them. But just for the sake of trying, I'm going to test this with a value. And what I see is something that I don't really like very much right now, which is the fact that the Z height is making these boxes grow in both directions. And so up and down. And if I'm thinking of these planes here as the base on top of which the box grows from, then it's not nice. It's not pure. So I think I want to control this better by, instead of using a box that is centered on a plane, instead of using that component, I would want to use a component that has a box that is controlled in size by domains. All right. What is a domain? A domain in Grasshopper is an interval between two numbers. So it's something that starts at a minimum value and something that ends at a maximum value. You can see that if I plug these guys here right now and I turn this one off, you can see that the default values are -2 minus 2 plus 2. These are -5 and 5. And C is from 0 to 0.25. And you can see that these boxes are indeed now starting from this plane as the base, which is an effect that I want much better than the previous one that I had. So what I can do is, I don't know if I can plug in this directly in here. Yes, so I can plug it in and it will convert the value of 1.75 directly to a domain that goes from 0 to 1.75. So what am I going to do? What I'm going to do is I'm going to take these values here and I'm going to convert them to domains that I can plug in here. So I'm going to do that by going here to the domain tab and constructing a domain. The domain is going to ask me for two parameters, the start of the domain and the end of the domain. The end of the domain, for example, for x is going to be 3.58, but for the start is going to be the same value in negative form. So I'm just going to use that negative form and I'm going to plug this into x, and you can see that now this value is controlling, because if I hadn't done the domain, if I hadn't created a domain and I had just plugged in y, you can see how the box is just growing in one direction only. Maybe that we could have gotten away with that. I don't think it's a very clean solution. So I think this is better. So I'm going to copy paste this. I'm going to create, I'm going to plug this in here, negative, negative, and you can see that very soon we're getting a spaghetti here. That's why it's very important to keep your Grasshopper definitions tidy and clean. I'm not sure if I will have time to do that now, but definitely when we post this somewhere, we will make the effort to clean them up and comment them a little bit better. Okay? Same for the inputs. Value and value is not a great thing to read. This should read like X size of the box, Y size of the box, etc., etc. Okay? Okay, so we're good. So we have a parametric definition with which we can create an array of concrete blocks that are separated a control parameter between each other. All right, so we're getting there. Okay, we love this kind of spaghetti. I am not sure if I love this kind of spaghetti myself. I try to be very clean and very ordered about my Grasshopper definitions, because otherwise, when you go back to them, it's the perfect recipe for a headache. But yeah. So okay, what is the next thing we're going to do? We're going to create the surface. All right. We're going to draw that in Rhino. We're going to import that surface, and then we're going to use some projection techniques to figure out the distance between the planes and that surface. Okay, so let's get going with that. The next thing we're going to do is, because we don't want a C height that is fixed for all the boxes, but we want those boxes to adapt to an undulating surface. What we're going to do is we're going to create a surface in Rhino that we will import into Grasshopper, and then we will perform some calculations to figure out the distance between the plane and that surface, and then use that distance as the height of these boxes. Okay? In order to do that, I'm going to go here to Rhino, and I'm going to physically draw a surface here in Rhino. How am I going to do that? I'm probably just going to make two curves, something like this. And now I'm going to make another one, something like this. All right. I'm going to maybe move one of them all the way here to the end, and then I'm going to loft them, I guess. I don't know. You guys probably you guys feel free to experiment. How do you think this could be done? And now I have this surface that I can perhaps center a bit better on top of here. And I may want to remove these two curves that I created. And I have now this surface, all right, that is floating on top of these boxes. I'm going to import that surface by creating an empty box to contain the surface. I'm going to right click here, set one surface. I'm going to import this here, and now in Rhino, so that I have a clearer view, I'm going to hide this object. And now you can see that I have this parametric, well, the surface is not really parametric, but that I have this surface on top of my boxes. The next thing that I will need to do is that I want to figure out what is the vertical distance between each one of these planes and the surface that is living on top of it. So what I will do for that is I'm going to perform a projection operation. I'm going to take all these planes, and because I know where they are, I'm going to take that point, the point that is at the center of the point of the plane, I'm going to project it vertically into the surface, and I'm going to figure out where it hits that surface. And after I do that, I'm going to have another point on top of that surface. I'm going to compute the distance between both of them, and then that's going to be the value that I'm going to feed into the C height of this of these boxes. Okay, so I'm actually not sure right now which component to use. Let me say project. Project a curve, project an object onto a plane, project a point onto a collection of shapes. I kind of like that, so let's see if this one works out. And I think there was a way to like figure out where, there was like a shortcut to like click a component and then figure out where it was on the ribbon. Can you guys help me out with that? Yeah, there was a component, there was like some kind of shortcut, like Control Alt something. Yes, this one. There you go. So it's Control Alt, and you see that info icon, then you click here, and then it tells me that it's under the vector category under points. No, it's not Alt Shift, it's Control Alt, yes. All right, cool, so it's this one here. And I see that pull point to a variety of geometry, so there's a lot of interesting. Let's try this one and see if it works, okay? I'm actually kind of going to pause the video of sorts. I will get back to that. So if this, okay, so what are we projecting? The point to project. I'm going to take here those planes. Well, I have the points here, so I can project those points here. The point to project, the direction of projection. That, you know what? It's a bit cleaner if I deconstruct the plane. I take the origin, and then I take the normal as a projection, and into which geometry. And you see, that's very nice. You see how I got all these points that are now projected on top of the surface? All right. Okay, so I'm just going to redo that because I think I was like mumbling a little bit. So let me redo that as well. So I'm going to pick it up from when I was explaining what I was going to do. So in order to do that, I'm going to use a project point. This component is a component that takes any point and any vector and projects it onto some geometry that we can specify. If you guys don't know where this component is, I can Control Alt and click here, and you can see that this component belongs to the vector tab inside the point category. It's project point here, all right? This component is asking me for a bunch of things. It's asking me for the point that I want to project, it's asking me for the direction of projection, and it's asking me for which geometry I want to project onto. Well, that one is the easy one. That's going to be the surface we just brought in. And for the points and for the directions, I want to keep it clean. So what I'm going to do is, because I want these planes to be exactly what I want to work with, I'm going to deconstruct these planes. This was here in vector plane. I'm going to deconstruct this plane into its components. So the origin, that is the point that I want to project. I could have taken it from here, but this is a little cleaner to do. And I'm going to use the normal direction of the plane, so the C height. I'm going to use that as the projection direction. And you can see that the result is that I'm getting this family of points that is projected on top of the surface right here. All right, so very easy now. So I can just go here, where is it, point, distance, or I can double click and type distance to compute the distance between 2 points, the origin of the plane and all the points that I just created. And if I use that, I'm going to move this all the way here. If I use that distance as the C height of my boxes, you can see that all these boxes are now adapted to the geometry of the surface. All right, isn't that nice? Let me disable the visualization of some of these things. Yeah, now. And let me do like a preview, custom preview. I think I'm going to render them pink. Yeah, but whatever, you know. Now, isn't this nice? Huh? The nice thing about this way of modeling the monument is that if I now unhide the surface, okay, and if I now touch the surface, activate control points with, for example, F10, and then I drag any of these control points. That was not nice, but if I drag it up, for example, you can see that everything adapts correspondingly, and I can hide the surface again, and I get this like massive bump as part of my modeling. So this is very nice because I have some kind of like very tangible way of touching the surface and adapting the overall design of the monument to this guiding surface, okay? So with that, I think I'm going to finish this first part of the tutorial. For the second part, I will be adding more detail according to the real the monument, and you will see somehow either on the screen here popping up as a card or on the video description, you will see a link to the second part of this tutorial. Okay, thank you very much. All right. Nice. Are they flat on top and they allow curved geometry? Yes, they're flat. They're flat because it's happening from boxes. You're right. Okay. I'm going to undo this. It's a very... All right. How are we doing? What do you guys think? To me, it's kind of awkward to do this like, oh, I'm now recording. No, I'm now tinkering, blah, blah, blah. But I think it makes sense and it will make things easier for people who watch these videos later, not to have to deal with all the mumbling and all the like, oh, what am I doing here, etc., you know? All right. All right. Can we have a video of making this in C# components? Oh, that's actually a pretty good idea. Yeah. We could. This is something very easy to replicate in one component, and that would be an interesting exercise to do in C#. I may write that down as an idea. Thank you for that. Yeah. Yeah. That's a pretty nice idea. Maybe that's the advanced version of this video. Maybe that can be part 3. Huh? Okay. Maybe we could do that. Let's do Rhino Common. I guess most of you are coming from my other videos, my C# videos, and you're like excited about C#. This is probably a little too basic for you guys, right? Well, we gotta cater to everyone. There was a point where none of us knew Grasshopper or C#, so let's take it easy, step by step, okay? I've been doing this for an hour already, and there's still 200 people here. Oh my God, I don't know why you guys are here and why do you deal with me, but again, I'm very thankful for this. Okay. Hope you're doing this more frequently. I will try to do this more frequently. You're right. It's like dance coding challenges, design challenges. That's a good idea. We could call this maybe we could start a series. Maybe we could start a series where maybe the series is about replicating buildings that are out there, because like I'm just doing the Berlin Holocaust Memorial, but there are many other buildings that have some kind of like geometrical interest. So we could do some sessions where it's about trying to replicate some aspects of those buildings, and we can call them the parametric building series or great buildings model or something. I don't know. Maybe that we could do that. Coming soon, parametric design of a building. Don't touch your eyes. Well, I did wash my hands this morning, and I haven't left my apartment, so so yeah, maybe that's a good idea. All right. Mini surfaces. Big fan of your Machina project. Well, thank you, Fagun. Thank you. I'm a big fan too. I put a lot of effort and illusion in that. Yeah, thank you. Coding challenge from research papers. Ooh, that's a big one. That's actually for very advanced people because, you know, research papers are like cutting edge research, so it takes some time for that knowledge to permeate and to be assimilated by the rest of us, right? Live stream is a good idea. All right. Okay. You know what I'm gonna do? I'm gonna take a 1 minute bio break before we go into the second part. So I'm going to put this on hold, just 1 minute, and I'll be right back. Okay? Okay, I'm back. I haven't gone anywhere. You guys still here with me? Um, in magical realization, this is why I'm a text. Icons generally are not too good drawn, in my honest opinion, but bifocals is a good. What is bifocals? I'm not really sure what you guys are talking about with that. Uh, Museum Sumaya, facade design. That could be an interesting project to do. Uh, Please share how do you set up your Visual Code Studio. We could do that as well. I think I have one of my videos on the Harvard playlist. I think like there's one where I literally explain where to set up. No, or I sent an email and then people did set up. People set up on their own with their email. I could show that. That's actually a very easy one to do. Make something with vanilla Grasshopper, then replicate with C# code. It's a series I would love to watch. That could be that could be an interesting. Uh, Sebastian, hi Sebastian. I didn't know you were here. How you doing? By Mark Sip. What are you talking? I guess you're talking about binoculars. What is that? I may have to look into that. I don't know what you guys are talking about, but I'll put it on my to-do list. Uh, It's a plugin that improves understanding of the components by adding component names over each one of them. Oh, that's actually a really good idea. Uh-huh. Neat Candela. um, that's also a really good example. I'm actually good friends with many of the people who designed that project, and we had in my class last semester, we had Mariana Popescu come over and give a lecture about that project. So just go to the playlist, go to my Harvard playlist, and you can watch a full lecture about how Neat Candela was done. It's really really cool. Somebody's asking if I teach at the MDE program. I currently don't, but I do have MDE students who have taken my classes. I just don't teach formally. And the MDE program is a program at the GSD. It's called Masters in Design Engineering, and it's a cross-transdisciplinary program between the engineering school and the design school. It's a really interesting master's. You guys should check it out. Uh, I'm doing okay, Mehmet. Thank you. I'm a little tired, but um, Hi. Is GH Sharp ready? Well, thanks for asking, Hari Prasad. Hari Prasad. It's not ready. it's way more work than we expected. So we kind of put it on hold a little bit right now, but I will hopefully find the time to gather my team again and put it together and make it publicly available sometime, probably in the fall. I don't even know. But yeah. All right. So should we get back to action? Okay. So thinking back again, we needed to do. What did we need to do? We needed to fit the grid to a polygon, for example, so that we have like a site of sorts. We needed to tilt the boxes a little bit, and we needed to make them fade out as they get close to the border. All right. So I guess those are the 3 steps that we're going to follow for this new video. Okay. Um, Somebody's asking, Kawaljit is asking, what is GH Sharp? GH Sharp is an open source project I'm working with some of my students, where what we're basically trying to do is we're trying to replicate each single regular vanilla Grasshopper component. We're trying to write the same component but with a C# script component, so that we can basically illustrate how those components work inside and how you would write the same functionality with C#. It's an educational project. For those of you who are interested in learning C# scripting within Grasshopper. I want to say we're 40% done. I think Katarina is somewhere on the chat. She is part of the team with whom we're working on this, so maybe she can join the conversation. Be careful, follow the headlines. There are 200 viewers. Yeah, that will be forbidden according to a lot of the new law and gathering regulations, right? Yeah, but well, I mean, this is the new norm, right? The new normal. Honestly, I think this situation will help a lot of us and a lot of people out there to realize that digital has so much more potential than we gave it credit for. A lot of people were talking about like how internet was making people less social and more isolated, but now that we have the pandemic, it turns out that internet is what's connecting all of us and what's saving our asses and not making us feel alone, which I think is kind of great and very interesting as a reflection. I think the implications of the new digital conversations we're having are going to stay for much longer than the pandemic, and they're going to become ingrained in our culture. Anyway, all right. So, oh, Greg is here. Hi, Greg. Good to see you. uh, okay. Um, where was I? I was, where were we? We were with the Berlin Holocaust Memorial, and we're going to record part number 2. Okay? All right, so let's get to it. I'm going to save this before I forget it. And then I will upload this file somewhere. I haven't thought of like a GitHub repo or for the files or where these things are going to go. Anyway, so what are we doing now? Okay, focus. Okay. Hi, and welcome to part 2 of this tutorial where we are modeling the Berlin Holocaust Memorial Museum in a parametric design tool called Grasshopper and Rhino. In part 1, which I just finished recording, what we did was we created like a simplified version of the memorial, what is basically a rectangular grid of boxes, all of them following this one guiding surface that we created here in Rhino. For part 2, I wanted to cover, so that was like more like a warm-up, like a basic for way of looking at this monument for beginners. But for this second part, I wanted to perhaps touch on more advanced features and try to implement some of the finer details that this monument actually does have in reality. And I think the three ones, the details that I would like to focus on are going to be, first, instead of sticking to a purely rectangular grid of boxes, we're going to try to fit this grid to a polygon that represents the site, because the site in the real world is not perfectly horizontal. It's not perfectly square. The second one that I would like to mimic is the fact that it's really hard to tell from the photos, but in reality, the plane in which these blocks are sitting is not perfectly flat, but it also has a little bit of an undulating pattern to it. So we can probably, I would like to replicate that also in this model. The third thing that I would like to do is, it's also very hard to see. You can kind of see in this picture here, but the blocks have a little bit of tilting to the sides. It's almost imperceptible, but it's there. I don't know if it's by design or if it's just the fact that it was very difficult to place them perfectly very vertical. So we will add a little bit of random tilting to these boxes. And finally, what I would like to do is I would like to implement this effect where as soon as close as we get to the boundary of the site, some of these blocks start disappearing, and that disappearance, that fading, is more noticeable the closer you get to the site, to the border of the site. Okay, so so those are the 4 advanced features that we're going to add to this model, to this model. So let's get to it. Let's get hands-on. Okay. All right. Okay, so the first one, what are we going to do? We're going to fit this to a polygon. That's going to be an easy one. Okay. I'm going to save this file too. Where is this? No, I'm going to save it to my desktop. It's going to be part 1. Okay. And now I'm going to save this as part 2, and I'm going to save this guy to part 2, Grasshopper. Okay. Any? Hey, Shireen. Good to see you. How are you doing? I didn't know you were here. Okay. All right. So let's keep going. So we're gonna do this. Yeah, we're gonna add a polygon, and we're just gonna. Okay. Okay. So the first one we're going to implement here is we're going to fit this grid to a polygon that has a non-rectangular boundary. First thing I'm going to do, I'm going to hide this from the view just because it makes things easier. I'm going to turn off this visualization component, this preview component, so that we can see things a bit more transparently. And again, just because if this was the real world, the site as a boundary would be something that would be fixed and we would not be able to work with parametrically, what I'm going to do is I'm going to draw some random curve or polyline in this boundary, and then I'm going to use that as the site. So that's going to be, for example, this. For example, I don't know. I'm going to take that inside of Grasshopper by double clicking and adding a curve parameter that I'm going to use to, what is it going here? What is going on? I'm going to select this curve and set this curve as the input parameter here. Okay. Now I'm also going to hide it, or not. I can hide that later. What I'm going to do is, before when I create all these points, before I start turning them into planes and operating them and generating boxes, what what I'm going to do is I'm going to filter all those points, and I'm going to remove the ones that fall outside of this curve perimeter. So in order to do that, I'm going to I'm going to pause here because I don't really know which component I'm using. I think there's something as in like, is point in curve, test a point for closed curve containment. I think this is the one that I want to use, yes. So going back. So in order to do that, I'm going to use this component here within the curve tab and the analysis category, and it's going to be point in curve, which tests a point whether if it's inside of a closed curve. For that, I'm going to feed all these points, I'm going to feed the curve, and what I get is a list of trues and falses. That is very hard to read here because this data is a tree, it's a data tree, but just for the sake of browsing it a little bit, you can see that I get a list of values 0, 0, 0 that go between 0 and 2. This is because this component, instead of just giving us true or false, it gives us numerical values because the result can be whether if it's outside, so that's a 0, whether if it's inside, that's a 2, or whether if it's exactly on top of the curve. Obviously, that's going to be very hard to do, but sometimes maybe some points will fall exactly on top of the curve within a certain tolerance. So what I want to do now is I want to filter this list of points and remove the ones that have a 0 as part of their containment criteria. Let me think about how I'm going to do that. Okay. All right. Let me see how I'm going to do that. I think I can just filter. Sorry, I haven't used regular Grasshopper for a while, which sounds pretentious, but it's kind of the reality. I'm sorry. Removed index elements from a list, call pattern, remove elements using a bit repeating mask. So I could turn zeros into, dispatch, weave, pick and choose. I don't know which one of these to use. Point in curve, call pattern. Somebody's suggesting that I use call pattern, so maybe I take this list. But if I plug in the pattern, then what am I getting? I'm getting 238. Oh, so it works off the bat because I guess number 2 doesn't get read. Huh. Okay. Okay, that's pretty good. Who was that? Yo13. Well, thank you for that. I didn't expect this component to work with the value of 2, but I guess that's kind of nice. All right, so we can do that. So I was here, right? When I stopped, I was here. All right. Equality and dispatch. That could have been a way to go as well. Yeah. Just equal to 0, equal to 2, and that gives us a true or false, and then we dispatch the list into 2. Oh, that's Kristen. Hey, how are you doing? Good to see you. All right. Okay. Sorry, I got distracted. Okay, so going back to the video. So, in order to filter these components, starting again. In order to filter those points, the ones that are 0s or the ones that are 2s, we're going to use here from the Sets tab, we're going to go to Sequences, and we're going to use the Call Pattern component. This component takes a list of whatever, points, data, numbers, and it just removes with a pattern the ones that are, it removes the ones that are false, and it keeps the ones that are true. Or the other way around, I'm actually not sure right now. It just keeps the ones that are it just keeps the ones that are true, and it removes the ones that are false. Let me just wait. Let me just. So 0 is outside, and those are cold. So those are gone. So 0, and because 0 is equals to false and everything else equals to true, the ones that are inside are kept. So false means it goes. All right. Yeah. False means, yeah, but isn't that not intuitive? If you want to call objects, you want to call calls the ones that are true. Yeah, true. Remove this component. Remove this point. True. No? It's kind of unintuitive to me. Is that just me? I don't know. Anyway, let's go back to this. So I'm going to start from the beginning again. In order to do that, in order to filter the points that are falling outside, we're going to go here to the Sets tab, and we're going to Sequence, and we're going to go to Call Pattern. What this component does is it takes a list of whatever, points, data, numbers, surfaces, etc., and then it filters that data by a repeating pattern of trues and false. So all the elements that are false, what was it? All the elements that are false are gone, and all the elements that are true get to stay inside of this filter. All right. The problem is that we have a list. We don't really have trues or falses. We have zeros or twos. But it just so happens that in computer science, when you do translations between numbers and Boolean values, the most common conversion between them is that anything that is a zero is considered as false, and anything that is not a zero is considered true. So 1, 2, 3, -1, -2 will be considered true. So this component does that conversion automatically for you. And you can see, if I hide all these boxes, you can see that this component has filtered, and it just keeps all the components, all the points that have a flag of 2 in there as part of their containment. So that's great. So if I filter that, and then I plug this in here, then all of my planes are only the ones that are generated by the points that are filtered, and therefore now I have a pattern of boxes that has been adapted to the boundary conditions of the site. Okay? Okay, so one thing less to go. I'm going to reorder this. This drives me crazy. Should I clean things up, and should I group things and tag them while I'm working with them? That would take a little bit too much time from the actual recording, right? Well, I don't know. Keeps true and call false. Yes. You can use shift pattern, you can use invert, dispatch. Yeah, essential algorithms. Suggest start thinking algorithm from end to the start backwards. Yeah, I was hanging out with Raja last October. She's so cool as a person. Oh my God. And and her contributions, her documents, her educational work is really great. Yeah. All right, so what was the next part? The next part was having like a bottom surface, right? And then pushing those points down there. Okay, so, okay, that should be very easy to do as well. All right, I'm going to save this. Good. The next thing that we're going to do is we're going to implement this feature where all the boxes, instead of being sitting on a perfectly flat surface, aka the XY plane, we're going to mimic a bit more of the reality of the document, where the floor is not really even, but it also follows like a very soft undulating surface. So what we're going to do is we're going to use a very similar technique to the one that we used to project the points to the surface above, but before creating those planes, we're going to take this family of clean points and we're going to project them to the lower surface, and then we will create planes on top of them, and then we will feed them, etc., etc. So that's going to be super easy to do. I'm going to do just like I did before. I'm going to create like a very softly undulating surface right below this thing. It's going to be right here. I'm going to create another curve. I'm going to deactivate object snap. I'm going to create another very soft curve, something like this. I don't want the effect to be very dramatic, okay? I just want it to be very subtle. I'm a minimalist, you know, so I like things clean and delicate. So I'm going to loft this, surf these two curves, 1 and 2. I'm going to create this other base surface, and here I'm going to bring it in, set one surface, this thing here. I'm going to put it up here, and now I'm going to hide it. Actually, I don't need to hide this one because it's going to sit on the base, so that's kind of nice. All right, maybe that can be the ground floor. Yeah, I'm not going to hide that one. Okay, and then I have all these points that have already been filtered. I'm going to turn this off. All these points that have already been filtered by the perimeter of the site. So what I'm going to do is I'm going to use just another instance of this component here, the project on points. I'm going to take all these points that are filtered. The direction that I'm going to follow now is going to be global -c. You can see that by default, that's the direction that the component is giving me. But I like things clean, so I'm just going to make sure that it's visual, that it's clear that the direction is -z. So I'm going to write here a panel with the values -1. I'm going to factor that z vector, and you guys can see that now it's pointing down, 0, 0, -1, and that's going to be the vector that I use for this projection. I like doing these things because sometimes when you open the definition, if you don't see what's plugged in here, it's very hard to understand what's happening. But if you see that there's a -1 and a z vector, it's easier to read, right? This is like code. It's like, imagine like a form of like commenting your Grasshopper definition. It makes it easier to read for other people. And then this is the surface that we're projecting on top. You guys can see now how all the points are on the surface below. And if I use those points now to turn them into planes, you can see that all the blocks are now starting from this bottom surface, and they're still reaching all the way up to the control surface on top. Okay, so okay, another thing successfully implemented. All right. Okay. Don't worry about grouping. Thank you, Fernando. But it's not good practice, okay? You have to group things, you have to label them. This is absolutely against what I preach and what I do in my personal practice, okay? That is not a good thing to do. Okay. What was the third thing? The third thing was tilting these blocks, okay? Well, that's going to be an interesting one. I may need to do some sketching for that one. How are we going to do this? We have the plane, so I guess we can take the plane. Can we take the plane? We can take the plane and we can rotate it around a vector. Is that the easiest way to do it? So if we have the plane, we can create like a random vector with 260 degrees around it. And then we also create like a random number for the angle. So from -2 to +2 is also a very subtle thing. And then we can rotate the plane around that. Vector. That sounds like a way to go about that. I may want to draw a sketch of that. I think so. Yes. So let's do that to explain that better. Okay. Great. The next thing we're going to do is we're going to implement the next detail, the next feature of the model, which is going to be that each one of the blocks has a small tilt. It's very subtle, but it tilts to the sides, and the angle at which it tilts is not always X or Y, but it's like, it basically covers the 360 degrees. So I think that's going to be an interesting thing to showcase here. And for that, I'm going to explain how I'm going to do it with a sketch. Okay, so we're going to shift to sketch mode, and I had this sketch. I'm going to wait. I'm going to go here, and I'm going to create a new sketch. So the way we're going to do this is going to be, we're going to work with each one of the planes, and this is very important. This is why when in the previous video I was making so much emphasis about not working just with points, but working with planes, because planes give us a lot of information about location and rotation. They're very nice to work with. So if we think of a plane, the way planes are represented in Grasshopper is by this kind of square that has a principal direction, that's X. That was a terrible line, sorry. It's very hard to do straight lines here. We have the Y direction here, and because planes are orthonormal, we have the perpendicular direction pointing outwards. That is usually not visually represented in Grasshopper, but it is there. It's information that we have. So that's the C vector. Okay. What we want to do is, we can't use, for example, a random rotate, because what that would do is it would rotate the plane around the C vector, and it will make the blocks not keep the alignment that they have on the grid. And we do want to maintain that alignment. So what we need to do is we need to figure out a way to create some kind of like virtual axis, for example, something like this, at a random angle from the main direction of the plane. So, for example, this angle can be random, and we may want to rotate that plane around this axis, also a random value. This is very hard to draw here. Also a random value. So I think the easiest way to do that is going to be to take each one of those planes, take the C vector, all right? So this is the C vector of the plane, sorry, the X vector of the plane, then rotate that X vector around the Y-axis a random value in degrees. So for example, something like a new X vector, something like this. This will give us the direction. Sorry, I'm just going to stick to the diagram that I did. So rotate that vector with a random direction, something like this, okay? And use that vector to rotate the whole plane by a random angle that will be very small. So let's try to do that. I'm going to shift back here. I'm going to take a detour here. I'm going to no, that's not what I want. I'm going to take this plane here, this collection of planes, all right? And I'm going to start working with them. So first of all, I'm going to decompose them, and I'm going to find the X vector, the main vector. So that would be the one that I specified here. So this one here. I'm going to then, for each one, and they're all the same. They're 1, 0, 0. Okay. So for each one of them, I'm going to. Should I flatten this? I'm going to flatten the list. Should I flatten this? I probably want to flatten this. That's going to be a pain in the ass. Well, it doesn't really matter, because if I plug them flattened, then everything will be flattened afterwards. So it doesn't really matter, because we don't need the structure anyway. All right. Okay, so let me cover that. And then you can see here that we have a data tree with all those X vectors, but we can also see that the data tree is kind of strange because, for example, it has an empty branch here, which due to the fact that we delete a full row of these blocks here, and then for each one of the branches, the number of elements is different. So that's going to make things a bit more complicated. So I guess what I'm going to do is from now on, I'm going to flatten the structure of the data tree so that from here on, I have all my vectors. I have them on one single continuous list without any branches. And since I don't really need that data structure for the rest of my exercise, that's going to make my life a little easier. I will have to modify a little bit of what's going on here, but it's fine. So once I do that, the next thing I want to do is I want to generate random values for the rotation of that x vector, one random value for each one of these vectors, and it has to be different values, okay? So the first thing I want to do is I want to figure out first how many vectors do I have. So I can do that by figuring out the length of a list, so list length. That gives me the value of 238, right? Now I'm going to go to sequence and place a random component. The random component, it tells me that first it asks me the domain that I want for the random values. It asks, so by default it's values from 0 to 1, but I'm going to be working in degrees, for example. So I'm going to change this to 0 to 360 degrees. If you write a domain with text and you plug it in there, it works pretty well. Okay, and since I don't want this to change ever, and this is very important, I don't want to use a slider for this, because if somebody touches that slider, then it's going to break the randomness of my distribution. So I want this to be always 0 from 0 to 2 to 360. Okay. How many random values do I want to generate? As many as elements in the vector, and this is the seed. The seed is basically a number that we can use to control the random distribution of these values. What basically this means is that each seed that we give, for every seed number that we feed the random component, it will generate a different kind of randomness. But if we always go back to the same seed, we will always have the same kind of randomness. Basically, this is just a way of saying, well, I can use, for example, any number, and if I change this number, the distribution of those random values will change. So we can try like different inclinations for these vectors. Anyway, by doing that, what I get is a list of random values that goes from 0 to 360, more or less. Okay? Now, what I can do is I'm going to take all these values and I'm going to use them to rotate this vector around the z-axis of the plane. I'm going to do that. There's probably something in transform, in Euclidean, rotate 3D. Yes. Well, I could have rotated the object in the plane, but this would have made my life easier now that I'm thinking about it. But anyway, now that we're here, we can just use this. So what is the geometry that we want to rotate? We want to rotate the planes. What is the angle that we want to rotate? I want to rotate this, but make sure that you see, it's already messing up. This is kind of cool, actually. But make sure that you here on A, because the input is in radians by default, make sure you right click and you hit degrees so that we stick to the 0 to 360 range. Then for the center, I want to use the center of each one of those planes, the center of rotation. And the axis of rotation is going to be the z-axis of each one of those vectors. Okay. So that should give me all this list of vectors. Oh, actually, sorry, I'm not rotating. Well, let's take a look at that. Where are these planes? They're here. Yeah. Well, actually, I made a mistake. I didn't want to rotate the planes. I wanted to rotate the vectors, but this illustrates, let me make these planes a bit larger. But this kind of illustrates how now we have randomly rotated vectors around. And I also, you see what's happening here? This is because I have forgotten to flatten. I have forgotten to flatten. So maybe I can just flatten this and then work with the planes instead like that. And then feed here these planes. That makes things better. Okay. All right, but it's not the planes that I wanted to rotate. It was the x vectors that I wanted to rotate. So let me redo that again. And now, what is going on here? The center is the geometry, raise geometry, because I need to rotate this around the center. Yes, okay. So because vectors don't have a location, sorry, that was my mistake. Because vectors don't have location, you can't really rotate them around the center. So they need to be rotated about 0, 0, 0. And you see that now we have this distribution of vectors rotated around that center. I think I'm doing this overly complicated. I think just rotating the plane and extracting the x vector would have made life easier for us. But anyway. Okay, so now that we have these rotated vectors, so yeah, let me show the other way that we could have done. We could have done rotate plane around, we could have rotated the plane a particular angle around its c height, and then just extracted the x vector from here. Maybe that's an easier way to look at this. I don't know. What do you guys think? Well, I'm gonna stick to what I did before, and then we can, because it's a bit more generic, which I kind of like. Okay, so we have those rotated vectors, and now we can use those vectors to rotate the plane around the vector. So just like I did this, so I'm going to go back and use this rotate 3D. And what I want to rotate now are the planes. So I'm going to take each one of these planes, okay? I'm going to rotate it around its center, so this thing here. The axis is going to be these vectors that I have created, and the rotation angle is going to be a random value that I will generate in a second. But you guys can see that immediately what I'm getting is that all of these planes are rotated by 90 degrees, and you can see how very interestingly they're all perpendicular to the plane that they were before, but they all have this kind of like inclined angle that is part of this random rotation that we gave it, okay? All right, so instead of sticking to 90 degrees, what we're going to do is we're going to create a new set of random values that go from, I don't know, -2 to +2, for example, or something that is parametrically defined. So for example, I'm going to copy this, okay? I'm going to copy this. I'm going to create a new, this is a new random sequence. But now the domain that I don't want that domain to be fixed. I want to have control if I want to have them more tilted, so very crazy tilting, or if I have that like V very constrained. So what I'm going to do is, I'm going to use a slider here, for example, that is going to start at 5 degrees. I'm going to create a domain that is going to go from negative -5 to +5, and then that's the range that I'm going to apply here for the random values. And here, so you can see how if I decrement this, all the values like damp down, but if I make this extreme, all the values like increase in proportionally, because I have not changed the seed. If I change the seed, you see that the distribution just like completely changes. So using these values, I'm going to create those planes, and look, this is very nice. If I do 0, there's nothing going on, but as soon as I start incrementing, you see how they are rotating? You see how they're rotating? The problem is that I am still using radians, so it's very pronounced. I'm going to shift this to degrees, and you see how like now the effect is much more subtle. Let me increment this to 90, but you see now how the effect is much more subtle, and as soon as I go to 90, see? All right, so I think we're good to go. So this was a lot. So I'm going to, my output is going to be this box. This is something that I like doing a lot. When I have something that is complicated, but it's kind of modular, so I took all these planes and I operated them to, I operated with them to rotate them. I like starting and ending with these empty boxes just because it makes things easier to plug with other elements from the definition here and then. So what I'm going to do is I'm going to plug this back into my definition wherever I needed planes. All right, so that was here and here. I probably want to move this to the side, and now you can see that, how nice is this, huh? You can see that all my boxes are like slightly tilted to the side, and it's actually a lot. So I'm going to decrease this value. You see, all the way until 0. Let me make this slider longer. So now you can see that, value, this is very cool. And you can also see how, because we're using the same seed, all those inclinations are, if I were to change the seed, the distribution of that tilting will change completely. All right? So I'm going to stick to, for example, the value of 2, which I think is subtle enough. You see, they're not perfectly aligned, but they're kind of aligned, you know? All right. And I'm going to hide a lot of what we did here, just because we don't need it anymore. Okay. All right. I think I ranted a little bit on that one. And perhaps using plane rotate would have made life easier. It's not the most optimal way, but it would have been simpler to do. How are we doing, guys? We generate a box, shift paths in TED. Yes, instead of rotation, we can use normal vectors of ground mesh for boxes. I see, random rotate. I mean, first, okay. All right, cool. Is it a good idea to rotate each one of them by its axis by itself a little bit? I'm not sure what you mean by that. By which axis a little bit? But anyway, we can probably take a look at that later. I want to finish, because something that I want to do as well, I want to finish this tutorial, and then I kind of want to open it up to Q&A and questions and have a conversation with you guys. I see we're down to 150 people. It's been 2 hours. I can't blame you, obviously. But I'm actually surprised that there's still 150 people in this thing. So I may just want to finish real quick with the exercise, and then I would like to open it up to questions and have conversations, and I would like to hear what you guys want to say about where could we take this, what other tutorials could we make. That's part of why I want to do this as a live stream. I want to hear something of you. And now that you've seen how this may look in the future, this like back and forth and conversation, maybe you have ideas on how to improve it or make it more fit to what you guys want to hear. Okay, so let's get to the last part. Also, my microphone battery is almost dying. So can you guys please, like, if you stop hearing audio, can you guys please tell me on the chat, because this may actually, should I just change the battery right now? No, I think we're good for like 20 minutes or so. If I lose audio, just like please write on the chat, because if I see a lot of stuff in this chat, I can see it from like the side of my eye. Okay? Livestream DJ set. Hey Cody, how you doing, man? That would be great. Maybe sometime. Yeah. Is that going to be a parametric live stream DJ set? Or maybe synthesizers. You were my master for that, you know? Okay. What are we doing now? We are, okay, the last one was figuring out a rule to remove some of those elements that are close to the, okay, so we may need to call, so how are we going to do that? So just like we have them here and we call them by how far they are before that, maybe we can just here in between, maybe we can just calculate the distance to the curve. And the shorter the curve is, the higher the probability we call them, and then we call them, and then we just plug them in here so that we have less, so that everything else is working here already with like clean planes. Parametric synths. Oh, just so you know, guys, there's kind of like a big lag between when I speak and when you guys hear me. I think there's something about, I think there's probably something, there's something in the range of like 10 to 13, 10 to 20 seconds lag. Yeah, I'm seeing it now. There's probably like 10 and 20 seconds between us. So that's why I'm not really that real-time responsive. So where was I? Yes. How are we going to do that? So the shorter the distance, the higher the probability. So we can do like an inverse probability. Yeah, we can probably figure that out. Okay. All right. How is the, I haven't asked, how is the quality of the stream has been so far? How is the audio and how is the video? Is it choppy? Is it blurry? Is it pixelated? Is it being fluid? Let me know in the chat, please. Thank you. Okay, so where were we? We're going to implement a rule to clean again. Stream is great, flow. Okay, oh yeah. Oh, thank you. Okay, so let's get to this. Finally, the last thing we're going to do is we're going to implement this like detail on the memorial where as soon as we get close to the boundary of the memorial, some of the blocks start disappearing, they start fading out. Okay, how are we going to do that? Well, I think that's going to be a bit more like algebra intensive. But basically what we're going to do is we're going to calculate for each one of the points. Let me first deactivate this. So remember here we had all the points that were clean and contained. These are the ones, sorry, these ones here, the ones that have not been projected back down yet. So we're going to work with these points, and what we're going to do is for each one of them, we're going to calculate the linear distance to the closest place on the curve. We're going to calculate the distance of that length, and then what we're going to do, we're also going to implement a random rule where the smaller that distance is, the higher the probability that that block should be removed. I'll get to how to do that in a second, okay? So first of all, let's figure out how far away these points are from the curve. What I'm going to do is, I think I'm going to go to curve, and I'm going to find, there was like something like closest point, curve, closest point. Find the closest point on a curve to the current one. I think this is the one that I want to use. So this is the points that I want to project on the curve, and this is the curve that I want to project onto. You can see here that a lot of points have shown up on the curve. Those are the points that have been basically projected to the closest point on that curve. And just to make it easier to see, I'm going to draw a line. We don't need this, but I'm going to draw a line between those points and the projected points so that you guys can see which one of those points has found its most proximal, its closest point on the curve. All right? Again, we don't need this line for anything. It's just for visualization purposes. Next thing I'm going to do is I'm going to calculate the distance between those points. That's going to be this guy and this guy. And this is going to give me, I don't need to see this anymore. This is going to give me a list of distances between a list of distances between the original point and the projected one. All right, I'm gonna drink some water. All right, it looks like the quality of the stream is still good. Thank you for reporting on that. Okay, and I need to think how to implement that random rule. So because the distance is very unlikely to be 0, we can just do like 1 over, we can just do a division where we divide. I'm just going to sketch something here. I'm not really sure where I'm going with this, but we can just say 1 divided by this is going to give me a number that is growing the smaller this value is. And then what I can do is I can say, well, now I'm going to create like a set of random values from 0 to 100. Okay? And if that value is smaller than this one, then that point should be removed from the list. And because we are doing an inverse, so look at this, because we're doing an inverse rule, you see that the points that are very close to the curve have a higher probability, and the points that are farther away from the curve have a smaller probability of being chosen. So that's probably what we want to do. Oh, the distance is already in the, okay, so yeah, so, that is true. So we don't need to calculate the distance, it's already in the component. Thank you, Kristen. All right, so I'll talk about that in a second, okay? And then once we're here, we have the probability of, so you can think of this as a probability. This point has a 2.3% probability that it should be removed. This point that is very close to the curve has a 6.32% chances of being removed, whereas this point that is very far away has a 0.06 chance of being removed, right? So yeah, I'm going to explain that. I'm going to go to recording mode, and then I'm going to explain that. Let me remove this. This was not what I was doing. All right. The next thing we're going to do is we're going to take those distances, and then we're going to implement a rule where we're going to remove points from that list based on how close they are to the curve. Okay. Somebody on the chat pointed out to me that I don't need to actually calculate the distance. The distance to the curve is already given by the project point on curve component, so this is unnecessary. Thank you for that. So here I have a list of all my distances, right? So what I'm going to do now is, because I want to implement a rule where the closest we are to the curve, the higher the chance we have of being removed, I need to somehow take these numbers, which are greater the farther away we are from the curve, and I need to somehow flip them so that for values that are very small, like this one, we have a higher chance, a higher probability of having that point removed. So I need to create big numbers out of small numbers, and I need to create small numbers out of big numbers, if you will, right? It's another way of looking at that. A very easy way to do that algebraically is by inverting those numbers. That's usually a way of inverting, is nothing else than saying dividing the number 1 by that number. So if I now copy and paste this and I show this here, you can see that by taking the values of the distance and doing 1 divided by that distance, what I have done is I have generated larger numbers from small ones and very small ones from larger ones. So you can think of this, we will use these values as the probability of the point to be removed from the curve. So for example, this point that is very close has a 2.3% chance of being removed from the list, whereas this point that is very far away, 16, has a 0.06% chance of being removed from the list, which is a very low value, okay? So, and how do we apply that chance? Well, imagine that we were throwing dice. So for each one of these numbers, we want to throw a dice, for example, a virtual dice, with a value that goes, for example, from 0 to 100, so that we stay in this like percentage kind of way of thinking. And then if the number that we roll is under the number that we have here, then that value should be removed. And again, because very small values give us higher percentages, it will happen that most likely those values, that those points that are closer, will have a higher chance of being removed. Okay? So let me implement that. So I'm going to say first, well, for random again, because we have this data structure that is not very nice to work with, I'm just going to flatten everything. Okay? I don't like, I'm going to flatten, this is going to break some things down here downstream, but I will take care of that later. Okay? So what I'm going to do is I'm just going to take these inputs here and plug them in here, and I'm going to flatten everything that's coming out of here. Okay? So now I have a clean list of points and random probabilities. And now I'm going to figure out the length of this list. So how many elements, how many points are in this list. I'm going to create random values for each one of those. So how many random values? As many as points on the list. What is the seed going to be? Whatever, I don't care. We can choose that later so that we can see different variation. And what is the domain going to be? I want the domain to be from 0 to 100, for example. If that's actually, I'm going to use a slider here in case we want to increment the chances. I will talk about that in a second. So I'm going to create a domain that is going to go. I'm going to construct a domain that is going to go from 0 to 100. I'm going to plug that in here, and you can see that the chances are these ones. So this number, blah, 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 blah. So basically, right now, no number is going to be under that. So that's, let me get to that. I'll get to that in a second. So, and then what I would do is I would check whether if the random value that I generated is smaller than this one. And if that's true, then that's what I want, and those are the points that I want to remove from the list. So I'm going to say smaller than, is this value smaller than the probability? And this is going to give me a list of false, 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 whatever. And then I can use, just like I did before, I can take a call pattern, take the whole list of points, and call it by this pattern. The only problem is that, as we saw before, call for elements that are false, it removes them, and for elements that are true, it keeps them. So I need to invert the sign of this Boolean value. So everything that is false, I need to turn it to true, or vice versa. Or what I can do is, like, instead of checking for whether if it's smaller, I can check whether if it's greater. So, for example, what is the, I don't know how that's called, larger than. Okay, so is this larger than this? True, 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 etc., etc. And this is the pattern that I use. So I'm going to hide this. And can you see, I mean, we had 238, and here we had 237. So there was one point somewhere, I can't really see, that has been removed. So something interesting is that because we have control over this domain, the domain of the random values, if we make this domain smaller, you will see how more and more values will start disappearing. You see? You see? It's very subtle, but it is, yeah. And you see how like this one is missing, this one is missing, this one is missing. I think this one is missing. This one is a bit farther away. This one is very far away. This was like a random chance. But we can see how there is like a bigger distribution of those elements missing the closer we get to the border, okay? With this one outlier. If we don't like that one, we can just change the seed and we can see how the new distribution just gives us this random outlier, but also we remove this one, this one, this one, this one here. So I think it's working, all right? Yeah, I like it, I like this. So we're gonna keep this, and this is going to be, this is the clean list of points. This is the one that we should project back to the surface. And then here, we don't need to, this is flattened already, so this is not going to change anything. And now we can activate this again, and we can see this random distribution. And we have the monument, and we have like they're slightly inclined, and you see how here there are some gaps here and here and here, and all the border is ta-da! Should I get like a bell or something like Dan Schiffman, like ta-chan? All right. Okay, so this is done. Obviously, this definition right now is hideous. It's terrible. It's really bad. It looks terrible. So this needs a lot of resorting and grouping and tagging of everything. But I don't know. Maybe that's something that you guys could help me with. What if I put this on GitHub and some of you took the time to clean it up, group things, make annotations, and then put it back on GitHub? I don't know, maybe that's something that we could do. But let me go back to the video and wrap it up, okay? So, as we just saw, in this second part of the video, we implemented a bit more like fine details and more nuances about how the monument is in reality. It required like a little bit of numerical manipulation and quite some randomness because of the random nature of the monument. But I think so far it's successful. This doesn't look like the real thing, but if I now change the scale of the surface and the plot of land, we could make it look very similar to that one. Okay. So thank you very much for watching, and we may follow up with a third part where we do this, where we implement this same thing, just in purely C#, in one C# scripting component. If that has happened, you will see here somewhere a card pointing to that video, or you will see a link to that video here in the description of the video, okay? Thank you very much. All right, and I think I'm very tired. I've been talking for 2.5 hours already. So I would like to spend like 10 minutes with whoever wants to stick around and get a little bit of your feedback. How did you think this went? What did you like? What did you not like? I will take these videos, I will edit them and make shorter versions of them and put them online for people who could not join the live stream, and also for people who doesn't want to sit here for 2 hours and just hear me like going back and forth. I understand it's not a great thing, but I would like to hear what you guys thought about this. What else we could do? What kind of exercises you guys would be interested on? I see a lot of people thanking for the stream. I thank you guys for staying here all this time. And yeah, I'm gonna I keep touching my face. I haven't left my house in like weeks, so all right. Is there a chance you could explain data trees in C# in Grasshopper? Oh, that's a very advanced topic. I can definitely explain that. Maybe we could do a video about that. But that's definitely something we can do. Yeah. It's not complicated, it's just tedious, but it's a very good thing to do. You might want to check Andrew Human's channel. He recently started. Yeah, I know. I'm aware of his channel. He's really good. I'm a very big fan of his work, and I'm a huge fan of his plugins. I recently discovered JSwan for JSON data manipulation, and I'm a huge fan of that plugin. It's really, really good and nice to work with. So yeah, I may want at some point, if this keeps going and I have like a better setup, I may would just want to invite people to stream and like do like dedicated sessions and focus areas on their expertise. So Angie would be like a wonderful candidate to invite. Um, Clapping to you, Merit. Thank you for sticking around too. Um, I like seeing the reality of how people think and work through problems. All right, if you like that, then probably the live stream is a good model for you, Mark. Um, yeah, that last part was kind of complicated. Yeah, that's why I think this two-level part, why breaking it down into like the simpler version and the more advanced version makes sense. And I also think that now it looks, the spaghetti is like really hard to digest. So it would need some work to like make things, put them in blocks. Uh, Please make stream for C# equations. That's definitely something I want to do. So yeah, we could start like a series on like C# scripting in Grasshopper, and maybe C# scripting in general without Grasshopper, or maybe start without Grasshopper and then move on into Grasshopper and discuss the relationship with Rhino Common. That's something we could do definitely. Uh, Mona Reese, Shireen, here to thank you. Are you able to dissect C-graph papers at all and make them easier to understand? You know, I have a hard time sometimes dissecting C-graph papers, but it's true, they're really nice. C-graph is one of my favorite conferences. But maybe we could try it. We learned so much with the back and forth. Oh, thank you. Is that you, Isabella? Uh, Thank you, sir. Thank you, Sarab. Looking forward to more. Hope you decide to just do it more often. Maybe. I mean, I have a lot of free time these days, so yeah, something like in the realms of the carambas and connection with other softwares. I haven't really done much that. Maybe set up a Discord. That's actually a good idea. I I may want to do that at some point. I'm a little overwhelmed right now by everything that's going on, but like, yeah, maybe give me a couple weeks and maybe geometry analysis. We will definitely cover a lot of those topics over the course of the weeks. So don't worry about that. According to which are the limits to use Grasshopper without programming skills? Well, Grasshopper is definitely designed for people without coding skills. The visual programming language paradigm is very easy to digest if you don't want to write a single line of code. And I did not really write a single line of code today. So I think that's a good one to stick to. Structural design, somebody else rooting for structure. You guys, big shout out to him. He runs the Fab Lab Malaga. What is your Instagram handle? Yeah, he runs the Fab Lab Malaga, and he's been printing facial masks for hospitals in the area for like a week already. So I want to give like a huge applause to my brother. I'm very proud of him, and keep doing a good job for the community. Oh, I didn't. Wait, I didn't. Yes, hospitals in Spain and in Malaga. I'm very proud of you, man. Caramba. Grasshopper tips. You mentioned having inputs and outputs on clusters, and therefore show how they come up with solutions and ideas. Well, isn't that kind of what I just did? I was like, because I didn't prepare. I didn't prepare to do this exercise. I didn't prepare. I didn't do the file in advance, and I was like, how and so. Some people are giving me good feedback about the thought process, so maybe keeping it like that. And if you don't want to bother listening to me going back and forth, and just like stick to the videos instead of the live stream, I get it, right? Not so much tutorials, more like jamming. I guess that's what we were talking about. Can we calculate with Grasshopper static of element? I think it's called finite element. There is some finite element possibilities. My advisor, Panayotis Michalatos, he has this amazing plugin called Millipede that can do FEA, finite element analysis estimations. So you should definitely check that out. General outline is good. Don't go in depth that much on, so you can add like a teaching lesson and make it genuine. Okay, um, that was quite helpful. I think you nailed it. Oh, thank you, thank you. All right. Um, all right. I'm going to. I have I have a full afternoon of meetings back to back until 4 p.m. So I think I'm just gonna call it a day. I want to say this very strongly again. I want to thank all of you guys for sticking for 2.5 hours here. I'm not sure if I would have done that for you, but I really appreciate that you found this useful and entertaining, and that this might be helpful for you. Okay, so I will at some point edit these videos, post them online. I want to read the chat carefully, what's happening or not, and then I'll see you guys next week, I guess. Thank you very much.